Pick up that salt shaker on your table. Perfect white crystals. The label says, pure, refined, 99.9% sodium chloride. You've been told this purity is good, that colored salt is dirty. But that purity is exactly the problem. Medieval salt routes built empires because mineral-rich salts from ancient seas were medicine disguised as seasoning. Your table salt? Chemically stripped, laced with anti-caking agents that can decompose into cyanide compounds. In this video, we expose why pure became poison and why the salt that built civilizations would be illegal to sell today. If you're ready, let's begin. To understand why your salt is chemically dead, we must first examine what modern industry considers impurities. This story doesn't start in ancient salt mines or evaporation ponds as you might think. This story begins in 20th century chemical plants, where the food industry became a side business of the chemical industry. The primary driver of modern salt production isn't feeding people, it's feeding factories. Industrial processes for making plastics, paper, textiles, and detergents require extremely pure sodium chloride. The chemical industry needs salt that's at least 90% non-Cal, with virtually no trace minerals that might interfere with reactions. So they developed brutal purification methods. Dissolve crude salt in water, add chemicals to precipitate out the contaminants. Magnesium, calcium, potassium, iron, trace minerals that humans actually need. Then recrystallize pure NaCl. Your table salt, a byproduct of chemical manufacturing, marketed as food. The irony is stunning. The minerals they remove, magnesium, potassium, calcium, are the exact nutrients modern medicine tells you to supplement. Your doctor says you need more magnesium for your heart, more potassium to balance sodium, more trace minerals for enzyme function, but those minerals used to be in your salt. For thousands of years, salt was the delivery system for these micronutrients. A pinch of ancient sea salt or Himalayan rock salt contained not just sodium, but a mineral spectrum that mirrored the composition of human blood plasma. Think about the absurdity. Modern nutritionists created the concept of the mineral deficiency epidemic. Magnesium deficiency affects an estimated majority of Western populations. Potassium intake is chronically low. Yet we deliberately strip these minerals from one of the most universally consumed substances in the human diet, then sell them back as expensive supplements. It's as if we removed all the vitamins from vegetables during processing, then wondered why everyone needs multivitamins. The physiological consequences are real. Magnesium is required for over 300 enzymatic reactions in your body: energy production, DNA synthesis, muscle contraction, nerve transmission. When you're deficient, you get muscle cramps, fatigue, irregular heartbeat, anxiety. Potassium regulates cellular fluid balance and blood pressure. Insufficient potassium means your kidneys struggle to excrete excess sodium, driving hypertension. These aren't theoretical deficiencies. They're epidemic-level health problems that correlate directly with the rise of ultra-processed mineral-stripped foods. And here's the cruelest irony. The medical establishment treats these deficiencies with isolated supplements, magnesium pills, potassium tablets, while ignoring that we actively created the deficiencies by refining whole foods into chemical fractions. Your body doesn't want a megadose of isolated magnesium oxide from a pill. It wants the synergistic mineral matrix it evolved with. A little magnesium, a little potassium, a little calcium, all working together in the ratios nature provided. But the mineral removal is just the beginning of the problem. After purification, table salt still has one flaw from an industrial perspective. It clumps in humid conditions. Sodium chloride is hygroscopic. It absorbs moisture from the air, causing the crystals to stick together. Consumers want free-flowing salt that pours easily. So the industry adds anti-caking agents. The most common anti-caking agent is sodium ferrocyanide, listed on European labels as E536. Now, don't let the word cyanide alarm you too much. The industry will assure you it's perfectly safe and biologically inert. And under normal conditions, that's mostly true. Ferrocyanide is a stable complex where cyanide groups are tightly bound to iron. Your stomach acid doesn't break it down. It passes through your digestive system unchanged. But here's what they don't advertise. Under high heat, or acidic conditions, ferrocyanides can decompose, releasing hydrogen cyanide gas. Is this likely in your kitchen? Probably not, but it's a synthetic chemical that never existed in any salt your ancestors consumed. It's in your food for one reason only: convenience. To make salt pour smoothly from a cardboard cylinder. And then there's the modern contamination issue: microplastics. If your table salt comes from sea salt that was harvested recently, it's almost certainly contaminated with microplastic particles. Ocean pollution has become so pervasive that every sample of modern sea salt tested in recent studies contains detectable levels of plastic fragments. These microscopic polymers, broken down remnants of bottles, bags, and industrial waste, are now part of the marine food chain, and they concentrate in evaporated sea salt. Ancient rock salts, mined from deposits that formed millions of years ago, before the age of plastic, are free from this contamination. When you buy Himalayan pink salt or ancient Celtic gray salt, you're accessing minerals that crystallized in prehistoric seas, untouched by modern industrial pollution. The irony? The impure colored salts are actually cleaner than the pure white stuff. Now let's travel back to the ancient world, to the salt routes that connected civilizations, to the trade caravans that risked their lives crossing deserts for loads of crystallized brine. Salt wasn't just a preservative. It was currency, it was medicine, it was a strategic resource that kingdoms fought over. And the most prized salts were never pure white. They were pink, gray, red, or amber, colored by the very minerals modern industry removes. Take Himalayan pink salt as an example. It comes from ancient seabeds in Pakistan, deposited when the Himalayas were still underwater, hundreds of millions of years ago. Spectral analysis of this salt reveals not just sodium and chloride, but up to 84 different trace elements. Iron, which gives it the pink color, magnesium, potassium, calcium, zinc, copper, manganese, and dozens more. The iron content alone is around 38.9 parts per million. That's not a lot, and critics will correctly point out that you'd have to consume absurd amounts of salt to get meaningful iron from it. But that's missing the point. The point is not that salt is a primary source of these minerals. The point is that ancient humans consumed a matrix of minerals in proper ratios from multiple sources. Salt was one piece of that mosaic. Every day, every meal, a little magnesium, a little potassium, a little iron, delivered alongside sodium. This created balance. Modern nutrition focuses on isolated nutrients. We say, take this magnesium pill, take this potassium supplement. But nutrients don't work in isolation. They work synergistically. Potassium and sodium, for example, are antagonists in cellular function. They balance each other. When you flood your body with pure sodium, from table salt, without the accompanying potassium, which used to be in the salt, you create an imbalance. Your cells struggle to maintain proper gradients across their membranes. Blood pressure regulation becomes harder. Ancient peoples didn't know the biochemistry, but they knew from experience that certain salts made them feel better. Himalayan traders paid premium prices for pink salt over white. Celtic healers used gray sea salt rich in marine minerals and clay particles. These weren't superstitions. They were empirical observations of physiological effects. Celtic sea salt, harvested from the coastal regions of France, retains its natural moisture and mineral content. It's never kiln-dried or chemically treated. The result is a gray, slightly damp salt that contains not just sodium chloride, but magnesium chloride, calcium sulfate, potassium, and trace amounts of iodine from seaweed. The moisture content itself is beneficial. It helps the minerals remain bioavailable and prevents the salt from being so hygroscopic that it clumps excessively. The historical evidence is clear. Salt routes like the Via Salaria in ancient Rome weren't just about moving preservative. They were about moving mineral-rich salt that had medicinal properties. Roman soldiers were sometimes paid in salt, hence the word salary, and they preferred certain types of salt over others. The trade value of salt correlated with its mineral content, not its purity. The economic importance of salt in the ancient world cannot be overstated. Cities rose and fell based on their access to quality salt deposits. Venice built its maritime empire partly on the salt trade from its lagoons. The Saharan salt caravans, where merchants crossed deadly deserts to trade salt from Taudeni for gold from Timbuktu, weren't risking their lives for sodium chloride alone. They were trading mineral matrices that kept populations healthy in environments where other mineral sources were scarce. In medieval Europe, different salts were prescribed for different ailments: gray salt for digestive issues, red salt for blood disorders. These folk remedies weren't magic. They were crude understandings of mineral therapy. A person with anemia benefiting from iron-rich red salt. A person with muscle cramps benefiting from magnesium-rich gray salt. The minerals did the work. Salt was just the delivery system. Think about the sophistication hidden in that primitive knowledge. They didn't have spectral analysis. They didn't know what iron or magnesium were. But they observed that people who consumed certain salts felt stronger, healed faster, had better endurance. They were doing empirical mineral supplementation centuries before modern biochemistry could explain why it worked. Now let's address the elephant in the room: iodine. This is the one point where defenders of modern table salt have a legitimate argument, and we need to be honest about it. In the early 20th century, large regions of the world suffered from iodine deficiency, leading to goiter, a large thyroid, intellectual disabilities, and developmental disorders. The introduction of iodized salt was a genuine public health triumph. Adding potassium iodide to table salt eradicated goiter in many populations and prevented countless cases of cretinism. So, the critics will ask, if ancient salt is so great, why didn't it prevent iodine deficiency? The answer is geographic. Iodine is abundant in coastal regions and in soils near the ocean. Populations that ate seafood, seaweed, or salt from coastal evaporation ponds got plenty of iodine. But inland populations, especially in mountainous regions far from the sea, had iodine-poor soil and iodine-poor salt. These are the populations that suffered goiter epidemics. The solution of iodizing salt was elegant. Take the most universally consumed substance and fortify it with the missing nutrient. It worked. But here's the problem. Instead of encouraging people to consume naturally iodine-rich foods, sea vegetables, fish, coastal salts, we created dependency on artificially fortified industrial salt, and we used that success to justify stripping all the other minerals out. Think about the logic. Because iodine is important, we added to stripped salt. But what about all the other minerals that were removed? Why not leave them in? The answer is, because the chemical industry doesn't want them. They interfere with industrial processes. Food is the afterthought. And here's the deeper deception. The industry markets table salt as pure and clean, implying that the minerals in rock salt are contaminants, impurities, dirt. They've convinced consumers that white equals clean and color equals dirty. But in the case of salt, the opposite is true. The color in Himalayan pink salt is iron oxide, rust, essentially. The gray in Celtic salt is clay minerals and trace elements. These aren't contaminants, they're nutrients. This linguistic trick calling minerals impurities is marketing genius. It reframes nutritional value as contamination. Imagine applying this logic elsewhere. Our refined flour is 99.9% pure starch. We've removed all those dirty vitamins and minerals. That sounds absurd when stated plainly, but it's exactly what happened with white flour, white sugar, white rice, and white salt. The refining process strips away everything that makes the food nutritionally complete, leaving a single dominant chemical compound. Modern toxicology focuses on what shouldn't be in your food: pesticides, heavy metals, industrial chemicals, and that's important. But we've forgotten to ask what should be in your food that's been removed. Refined salt is the ultimate example. It's not contaminated with poison, it's contaminated with nothing. It's been purified into a single chemical compound when it should be a complex mineral matrix. The irony is that the chemical industry's need for ultra-pure sodium chloride created the standard that consumers now believe is superior. Industrial chemists needed pure NaCl for their reactions. Food manufacturers found it convenient because it's standardized, cheap, and doesn't vary. Marketing departments turned necessity into virtue. Look how pure our salt is. And consumers, trained to fear chemicals and love purity, bought the lie. The defenders of table salt will say, but you can't get meaningful amounts of minerals from salt anyway, so it doesn't matter if they're stripped out. And that's partly true. You shouldn't rely on salt for your magnesium or iron, but the cumulative effect matters. If you strip minerals from salt, from flour, white flour versus whole grain, from sugar, white sugar versus molasses, from rice, white rice versus brown, from every processed food, then over a lifetime you've removed a significant mineral intake that humans relied on for millennia. The deficiency isn't acute, it's chronic and subtle. And when it shows up as muscle cramps, high blood pressure, or fatigue, you're told to take supplements instead of being told that your food was gutted. So, in light of all these chemical facts and historical evidence, what should you do? The answer isn't to throw out all your salt and panic. The answer is to make a simple, informed swap. That cylinder of Morton's, or generic table salt, finish it if you want, or just replace it. Buy unrefined salt. Look for Himalayan pink salt, Celtic gray sea salt, or other ancient rock salts. Yes, they cost more, maybe 2 or 3 times the price of table salt. But salt is cheap. Even expensive salt is one of the least expensive foods per use. A pound of Himalayan salt might cost $5 and last you months. When you buy unrefined salt, you're not just buying flavor. Though it does taste better, more complex, less harsh, you're buying a mineral spectrum that your body recognizes. You're avoiding synthetic anti-caking agents. If it's rock salt, you're avoiding microplastics. And you're reclaiming a small piece of ancestral nutrition. Now, should you worry about iodine? If you eat seafood once or twice a week, or if you consume seaweed, nori kelp, you're probably fine. If you're completely inland and never eat ocean foods, consider an iodine supplement, or buy iodine-enriched sea salt. Yes, such products exist. Sea salt with natural iodine retained or added back. The point is, don't let iodine be the excuse to keep consuming chemically stripped salt. If what you heard in this video made you realize that pure has been a marketing lie and your table salt is mineral dead, show it with a like. Now it's time to be honest. Open your pantry right now. What kind of salt do you have? That white cylinder with the girl holding an umbrella? Or unrefined, colored, mineral-rich salt from ancient seas? Write in the comments. Let's see how many people are still using industrial byproduct as food, and that health-conscious friend who obsesses over organic vegetables but still uses refined table salt? Send them this video. Maybe this will be the moment they realize that purity isn't always healthy. We will continue exposing how industrial improvements remove nutrition in this series. In the next video, we're diving into vinegar. How did medieval Four Thieves vinegar kill plague bacteria, while your modern distilled vinegar is just diluted acetic acid? The answer involves living biofilms that modern industry killed. You don't want to miss that microbial mystery. Until then, stay salty, stay skeptical, and most importantly, stay real.